Hello, I'm Alexis Pellick of Process Development Forum, and I'm here today with Professor Jürgen Hubbuch of Karlsruhe Institute of Technology. We're talking today about high-throughput process development. Professor Hubbuch, thanks for joining us.
It's a pleasure from my side.
Can you summarize briefly what high-throughput process development is, and for what kind of processes is it useful?
Well, HTBD, which is the shortcut of high-throughput process development, has evolved from screening approaches in the field of chromatography on modern liquid handling station approximately a decade ago. Since then, it developed into a new methodology how to develop modern purification processes, especially in the biopharmaceutical industry. HTBD in its present form rests more or less on three important pillars. The first one is the ability to perform high-throughput experimentation in any field and for any unit operation in focus. The second pillar lies in the existence of adequate analytics to deal with the huge amount of experimental systems investigated during high-throughput experimentation. And finally, the third pillar deals with the design of experiments to be performed. Data handling and storage, data analysis, either using statistical or mechanistic models, and finally the translation of the obtained data in process-relevant information. So if we sum up the methodology and experimental procedure behind HTBD, is useful for all process steps during biopharmaceutical production, from upstream over downstream to formulation. Focusing on downstream processing, HTBD strategies exist already for all major unit operations, ranging from solubility studies over aqueous to phase systems up to chromatography.
I see. Thank you for that explanation. So different formats for chromatographic screenings are on the market, such as plates, columns, etc. Do you see one format being better than another in general?
Indeed, chromatography being the workhorse in our industry is the most widely examined unit operation, with a great commercial coverage of different screening formats, such as typical examples are predictor plates from GE Healthcare, tips from Finexus, or RoboColumns from Atoll. And clearly, there is no general answer to what format is superior. This simply depends on the question to be answered. A modern HTBD lab will probably have the equipment to utilize all different formats and the experience to choose the adequate technique depending on the objectives of the screen.
So are there any specific applications where one format is better than the other? Can you tell us a bit about how particular formats are best suited to the particular applications?
Well, the answer is, of course, not straightforward. I think it mainly depends on restriction you have concerning available time and material, and also very much on the insight into the theory of chromatography of the individual performing the screening. Regarding time and material, clearly all batch formats, for example, predictor plates or in-house procedures, are superior as they enable the user to cover huge experimental space with a limited amount of material in a short time frame. The advantage simply lies in the ability to perform the experiments, either 96 or 384 volts, and the forwards, such as multiple plates, as such in parallel. If one wants to name typical applications, let it be screening for different resins, pH, ionic strength, and or salt type combinations. On the other side, RoboColumns might come at first sight closer to the actual process at lab scale. This said, there are still clear differences in terms of achievable residence times and fluid dynamics. If one wants to combine both formats, then a wide and rapid screening using batch followed by a narrower, more defined screening window using RoboColumns might be appropriate. This said, we have two extensions which should be kept in mind. The use of mechanistic models in chromatography will significantly change the way screening is performed today and reduce time and material. Here it is clear that a combination of batch and modeling will be sufficient for rapid process development. On the other side, RoboColumns might find their excellent niche in sample handling and pre-treatment during large HTBD workflows as such, where they are clearly superior to the batch formats, and the competition between RoboColumns and tips might be seen in this.
Okay, well, thank you for that detailed explanation. So HTBD produces a lot of data, and some people feel this results in new bottlenecks. Which are, in your opinion, the major bottlenecks at present?
Indeed, with the ability to perform and analyze a huge amount of systems, data has increased accordingly. Nevertheless, we need to distinguish between the situation in smaller units where HTBD methodology as such is applied, but due to the rather few systems investigated, the amount of data is not an issue as such. And on the other hand, the situation in large companies where more than one liquid handling system is running 24/7. So for the latter situation, the current problem lies not so much in the general ability to deal with data of this size, which is very small when compared to other fields, but rather in the still missing awareness of the importance of this step within the overall workflow. In the traditional mindset of people, the main task lies in performing experiments, followed by analytics, and after a wide gap, looking rather subjectively at the data using simple spreadsheets. Thus, while the first two steps have greatly evolved, the data handling step is still done individually and along the lines what has been done 5 to 10 years ago. This mindset, of course, is bound to fail in the current situation and future progress in this field. However, database applications to perfectly deal with this situation are available, and where appropriate, they simply need to be installed and applied, I think.
Okay. So at present, what is the top challenge when it comes to HTTP?
Well, top challenges, I think, are fourfold, and they lie in A, the combination of mechanistic models and scientific theory and experimental screening towards model-based design of screening approaches. B, more on a hardware side, the realization of errors arising from the miniaturization as such, and thus the validation of the data obtained in terms of meaningfulness, robustness, and scalability. C, the integration of up and downstream screening procedures. And finally, the combination of these points with the economic total process or site-specific considerations.
Professor, can you describe a future general workflow for working with HTTP?
Okay. Due to the complexity and the wide range of applications, there's no general workflow, I think. When it comes to chromatography, as a simple example, I would personally approach it the following way. I would start with a wide screening of resins and fluid phase conditions to map the overall matrix in the batch mode, say predictor or in-house applications, then followed by a further refinement of the promising windows, again in batch mode, and both assisted by statistical software packages. Finally, on top of this, if the complexity of the system allows it, this should be followed by batch or robocolumn screening to determine data needed for subsequent usage of chromatographic models for in silico simulation of column chromatography. I personally think that this will be the future. But at present, if the feedstock complexity does not allow it, one would do a final refinement using probably robocolumns before going to a 1 mil scale on a FPLC system.
I see. That's an interesting approach. Well, Professor, thank you so much for sharing your insight with us today.